In Chapter 8, we look at additional types of topics in trigonometry. In the first part of Chapter 8, 8a, we'll look at right triangle trigonometry, and then we'll look at triangles that don't contain a right angle and how to utilize sine and cosine to find missing values. In 8.0, we're just going to do a little right triangle refresher. It says when solving for a side length in a right triangle, the following options are available. You could do Pythagorean Theorem. If you know two of the three sides, you can find the missing side by taking a squared plus b squared equals c squared. You could also utilize Sohcahtoa if you know an angle measure. Other options, you could do, well, that's actually kind of it. Never mind, I guess those are our only two choices for that part. That's fun. When solving for angle measure, we have more options. The nice thing about right triangle trigonometry and pretty much everything we do in Chapter 8 is we're always going to be in degree mode. Make sure your calculator is in degree mode and you shouldn't have to convert to radians for anything we do in this chapter. So here are options to find angle measures. When given a right triangle, you can do the inverse of Sohcahtoa, like sine -1. To take the inverse, you'll have to know two of the three sides in the right triangle to make that happen. You also can subtract your angles from 180. In any triangle, whether the right triangle or otherwise, if you have two angle measures, you know their sum must be 180 degrees. Therefore, if you're trying to find a missing value and you know two others, add them together, subtract from 180, and there you go. Now, when we're asked to round, rounding rules are going to be pretty unique. If you're solving for a side length or an angle measure, you round your answer to the nearest tenth of a degree or tenth of a side length. But if you ever enter a trig value, like sine of 35, for example, and you write out what that answer is, you want to go to the nearest 4 places, and that would be the 10,000ths place. The further out you go with your trig function, the more accurate your result will be. And we'll try to follow the template of not having to approximate your trig value at all. We're going to leave our trig values in all of our answers and then enter them in our calculator all at once. Often in word problems, you're going to hear a couple of different phrases. And I just moved that, sorry, didn't mean to. You're going to hear a couple of different phrases that will help you determine your location inside the triangle. If you ever see angle of elevation or angle of depression, notice their locations in the picture. So we see that airplane and it's up in the sky looking down at the watchtower. Notice the angle 2 that's on the outside is called the angle of depression. If we were to draw an altitude down to the bottom, that angle's not inside the triangle. However, on the bottom, from the air traffic control tower up to the pilot, the angle of elevation is. Now, the airplane pilot is looking out at what's called a line of sight. If you look straight out, that's known as line of sight. And if the traffic controller has a line of sight as well, when they look straight out, those lines would be parallel to each other. And if you have two parallel lines cut by what's called a transversal, that angle on the top, the angle of depression, and the angle of elevation are the same. So that angle at the top, angle 2, would be the same as angle 1. Therefore, if you know one measure or the other measure, you can plug them in simultaneously in either location. Just recognize that the angle of depression is not on the inside of the triangle. Okay, so we're going to start off just by looking at triangles themselves, and then we'll end with word problems. When you're asked to solve a triangle, you want to find all missing sides and angles. It could be 1, 2, or 3. Find all sides and angle measures. First thing you want to do is actually create a triangle and plot the given information on that triangle. It says we're given triangle DEF. We've got our triangle symbol. D, E, and F are the three vertices. Notice it says right angle E. That's going to be significant when we draw our picture. I'm just going to sketch a triangle over on the side, like so, and I'm going to draw my right angle in the corner. Now it says that angle has to be E. I'll mark it as such. D and F, you can write wherever on either side. I'll put D at the top and then F over at the bottom right-hand side. There's triangle DEF with right angle E. It says DF has a length of 20. So from D to F, that would be the hypotenuse. And then DE, that vertical segment on that left-hand side, has a length of 6. So those are the things we know about this picture. We know one of the angles and 2 of the 3 total sides. When you're asked to solve, that means we have to find the rest of them. So here's what we can do. If we know 2 sides, remember looking up above, we have Pythagorean Theorem and Sohcahtoa as options. Now unfortunately, Sohcahtoa only works when you have an acute angle, meaning less than 90. So angle E isn't going to help us with Sohcahtoa. Therefore, we're going to have to do Pythagorean Theorem. To find EF first, we'll think A squared plus B squared equals C squared. Now remember, C is the hypotenuse. We have to put the 20 on that side. 6 can be the A or the B. That really doesn't matter. I'll call it A, or I'll have A squared be our bottom, and then B squared will be our 6 squared, and then we'll solve. A squared plus 36 is equal to 400. Subtract 36 from each side, and we get A squared equals 364. Take the square root of A, and we want to have an approximation. Remember in the directions it says to the nearest tenth. If we take the square root of 364 to the nearest tenth, that's approximately 19.1. That would be the approximate length of EF. 1 down, 2 to go. Now we need to find our missing angle measures, angle D and angle F. Doesn't matter which one we pick, we need them both. I'll start with angle D. If D is my reference angle, the 2 side lengths that were originally given were the 6 and the 20. From angle D, they would be adjacent and hypotenuse. Going back up to Sohcahtoa, we can do inverse Sohcahtoa if we know which trig function would match adjacent and hypotenuse. That would be cosine. We start with our angle, cosine of angle D. That will equal the fraction adjacent over hypotenuse, which is 6 over 20. That's a 6, not a B. To get D by itself, we just take the inverse. And what makes this unique from chapter 7, we're not finding angles on our unit circle, we're just trying to solve the acute measure for our triangle. In degree mode, if you type in cosine inverse on your calculator of 6/20, you would get approximately 72.5 degrees. And now our third angle measure. You could take this angle and add it with 90 and subtract from 180. However, if for some reason angle D was incorrect, angle F would also be incorrect. I always like to keep inverse Sohcahtoa just in case one of my answers is wrong, then we know that both of them would not be wrong. To get angle F, I'm now going to look at this as my reference angle, my theta location. Now 6 is opposite and 20 is hypotenuse, and that would be the sine ratio. Sine of F is the same fraction as the other one, but now we're going to do sine inverse instead of cosine inverse. And if we take sine inverse of 6/20, angle F would be approximately 17.5 degrees. And that's using Sohcahtoa, Pythagorean Theorem, to find all missing sides and angles in a right triangle. All right, everybody, let's try the next one. What I'd like you to do is pause the video. See if you can draw triangle ABC with right angle C, Angle A at 35 degrees and the length of segment AB is 14. Then press play and we'll see if we get a match. Hopefully your triangle looks something like this when you're done. Now notice this time we're given two angles and only one of the three sides. If we know two of the three angles, the first thing we can get pretty quickly is the measure of angle B. Angle B would be what we'd get, that's an angle symbol, sorry, it looks like an L. Let's try to make that an angle. There we go. Angle B should equal 180 minus angle C, which is 90, minus angle A, which is 35 degrees. The measure of angle B should equal 55. We didn't need to do any inverse Sohcahtoa for that one. Now we have two missing side lengths. We have BC and AC. It doesn't matter which one you pick, we can solve both of them. I'm going to pick BC and just call it X. From angle A, which is 35 degrees, X would be the opposite side. And AB, which is given, is the hypotenuse. Therefore, if I take sine of angle A, that would equal X over 14. And angle A is 35 degrees. Sine 35 equals X over 14. This is one of those situations where we want to get X by itself first, and then we plug it in and we don't have to worry about trying to round sine 35. To get X by itself, I'm just going to multiply both sides by 14. That cancels on the right and X is by itself. We'll do the squiggly equals. If you type 14 times sine 35 into your calculator and you round your side length to the nearest tenth, it's approximately 8.0. Then we have to do the same thing for AC, the length of that side, the vertical segment from A to C. To get that side length, I'll call that one Y. From angle 35, Y is now the adjacent side, meaning that would be cosine of angle A, which is 35 degrees. We don't have to write out A, I guess. That equals adjacent over hypotenuse. To get Y by itself, multiply by 14 on both sides. 14 times cosine 35 would be approximately 11.5. And that would be the third value we need to find. So we've got angle B, which is 55 degrees, side length BC, and side length AC. And that's what we'll do to start off Chapter 8, 8.0. On Monday, we'll finish with a couple of word problems, and then I'll have you try some problems on your own.